Alright, welcome back to Who Wants to Be a Mathematician. I'm your host, Mr. Hill. Here we go, coming at you, the last part of Families of Graphs packet. And we're going to throw a little curveball to you. We're going to start off with, oh my gosh, the graph. And then we have to find their equations. Crazy! Alright, you know what? Let's just dive right into it. Who's scared? I'm not. Alright, here we go. So a couple things we got to look at. One is, where did their center point move from? So, parent graph, step one. Parent. So what is the parent of example A? Kind of looks like, I don't know, our good old friend x cubed. So here we go. Y is equal to x cubed. Starting off nice and easy. Now, our parent graph of x cubed has this little dot. But where is that little dot originally? Well, it's originally over here, right? At 0, 0. So how far have we shifted from that point? Well, it kind of looks like we've gone right 1, 2, 3. We've gone right 3. And how many have we shifted up? Kind of looks like we've gone up 1. So if we've gone right 3, let's do it like this. If we've gone right 3, what does that mean? That means that we are subtracting 3 from it. Crazy, I know. What means that we're going up 1? Well, that means that our quantity x minus 3 cubed is going to be added to 1. So our new purple graph, our purple graph's equation is y is equal to our quantity x minus 3 cubed plus 1. Bada bing, bada boom, we're done. Step 1, find the parent graphs. Step 2, find the shifts. It's the same thing. Alright, let's look over at B. So step 1, parent. What's the parent? I don't know. It kind of looks like the square root of x. If you look at the parent graph square root of x, it's kind of what it looks like. So 2, we're diving into the shifts. What does the original square root of x look like? Well, it starts off here and goes up like that. But it shifted. Oh my gosh, who would have thought that it shifted? It shifted down over here. What did we do? We went down 2, and we went left 2. So now that we know we've gone down 2, left 2, there's one more piece. It's upside down. So what does that mean? What did it do? Reflected. It reflected. It's upside down. It's lost. It's confused. It's reflected. So 2. We went left 2. So what does that mean? Y is equal to the square root of x plus 2. That's what left 2 means. And down 2, what does that mean? Y is equal to the square root of x plus 2 minus 2. And if we reflect, what does that mean? Y is equal to negative x plus 2 minus 2. So what is our purple graph's equation? It's y is equal to negative x plus 2 minus 2. Done. Alright. So work on C by yourself. Think about what the parent graph is. Do a small little sketch of what the parent graph is. And then we're going to go over it. So pause me. Don't listen to me anymore. Go on step 1. Find your parent. Find your parent graph. Then 2. Talk about the shifts. Alright, pause. No, seriously, pause me. Alright, and we're back at it. So parent graph. What does it kind of look like? I don't know. This parent graph looks like a V in the air. He threw up his lines like he just didn't care. that v is equal to the absolute value of x. So now, we know our absolute value of x starts here and goes off like this. That's what our parent looks like. So now let's talk about some shifts. How did we get to where we are today? We shifted left 2. We went 2 units to the left. Not only that, but we kind of got steeper, right? These lines are closer together than our parents are. It got steeper. How much did it get steeper by? Oh, well, we can tell that by looking at the slope. Remember, steeper means that there's a bigger slope. So on our parent graph, if we look at our slope, rise over run, we've gone 1 and 1. So it's a 1 over 1. Over here we have 1 and 2. So that means this graph is steeper by 2. 2 times steeper. All right, let's talk about our shifts. We're going to clean this up a little bit. Kind of just, oh, nope, that's not cleaning it up. Yeah, here, let's get rid of some of this stuff. Got a little crowded over there. So if we come back here, we got steeper by 2. All right, so our shifts, we have a left 2. What does that mean? Y is equal to our quantity x plus 2. Left 2, we've added 2. How about our steeper? What is this? This is by 2. Steeper by 2. So y is equal to 2, getting steeper, and adding that. So what does that mean of our purple graph? Its function is y is equal to 2x plus 2. If you got that, good job. Nice. If you forgot about the steeperness, you just got to remember to graph the parent graph and look, is it the same or is it steeper, shallower, all that good stuff. All right, move on to D, into practice. And what? You're going to look, ooh, that's the wrong color. 1, you're going to look at parent. And 2, you're going to look at shifts. So find your parent graph, do a quick sketch, and then find out how that has shifted. So pause me. You're done. I'm paused. Alright, you should have had some time to work on it. We got a clean slate here, so let's look at our parent. 1, our parent graph. It's kind of looking like 1 over x, isn't it? It has that weird center point at 0. Kind of goes up like, ooh, bad, Mr. Hill. That is not what it does. It comes from here, goes over here. Yeah, it kind of looks like that. There's only a couple differences. What's the difference? Number 1, we've shifted. We've gone over how many? We've gone right 1. Right 1. We've moved over right 1. And the pink lines don't really line up with the blue lines. It's a little something going on. What do we call that? Reflection. So, right 1 and reflection. So 2, we're talking about our shifts here. So if we gone right 1, what does that mean? That means y is equal to 1 over, because our quantity is moving right 1, so it's x minus 1. Good. And then we have our reflection. Ref. So that's y is equal to negative of our quantity 1 over x minus 1. So what is the graph's final equation? It is y is equal to negative 1 over x minus 1. And there you have it. That's what this whole purple thing looks like right here. Come on. Right here is negative 1 over x minus 1. And there you have it. That's going to be Families of Graphs in a nutshell. Thanks for watching. I'm Mr. Hill. See you next time.